Okay, people, can't be there with you. Sudden emergency at home, and I gotta stay here. And so, I know that we have a very long period together. I have two different videos, but they're both going to be fairly short as long as you're paying attention. I'm going to review some of the exponent rules that we have and introduce to you a exponent rule number 6, number 5, and then number 6. Okay? My expectation is that you become very comfortable with exponent law number 5. That is, what do you do when you have a negative exponent? And then get your feet wet with rational exponents and doing some questions together. I imagine this might still be a little bit weird and you need lots of practice. And it's so important that I tell you this. Your exit card on Friday requires you to have lots of practice. So you can't expect doing practice at school be enough. You are not going to be successful. So make sure you do some at home. Okay, you have Wednesday and I'll be there. You have Thursday and I'll be there. That's your goal. So let's talk. If you looked carefully at this handout, you will see the first page is just a breakdown of all the exponent laws you've done so far, plus the negative exponent. Okay? And on the back side, there's a bunch of really scary looking questions that we are going to try together soon. Okay? We'll try some of the harder ones together so you get your feet wet on using multiple exponent laws at the same time. Okay? With that said, if you want to do some examples with me, you might want to take out a piece of paper. Otherwise, follow along. Today's exponent law is actually very simple. That is, what do you do when you have a negative exponent? So I am going to ask you to mentally follow along as best as you can. And if you aren't following along, you can watch this video again. I have a pattern that I like you to consider. 2 to the power of 1. 2 to the power of 2, so the exponent increases. 2 to the power of 3, and the exponent increases. And 2 to the power of 4, the exponent increases. What happens to the total value, or the evaluated value? 2 to the power of 1 is just 2. We're multiplying 2 once. 2 to the power of 2 is 2 times 2. We are multiplying the value 2 twice. This is also the same as take the previous value and multiply it by 2. And that is equal to, let me rewrite this. That's a 4. So that's like take the previous 2 and multiply it by the base. I'm going to do this just so that you remember what we're doing. It's not a 3, it's not a 4, it's always a 2 because the base is a 2. 2 to the power of 3 is, you might have guessed, 2 times 2 times 2. And that is the same as taking the previous value, 2 times 2, and multiplying another 2, or another base to it. So let's get the pattern. If the exponent goes up by 1, so plus 1, I am multiplying by a 2. If the exponent goes up by another 1, I am multiplying by 2. And if the exponent goes up by another 1, then I am multiplying the previous by another 2, and that will be 16. And so 8 times 2 is 16. I hope everyone's good. We're going to use the same pattern to prove, or not prove, but to show that it is consistent with our exponent law number 4. That is what happens when the exponent is a 0. Okay? So erasing this, if I go up an exponent, I am multiplying by a 2. But what if I go down an exponent? So once again, if I'm going up an exponent, I multiply by 2. So the opposite direction, if I subtract the exponent, I am dividing by a 2. So 16 divided by 2 is 8. If I go down an exponent, 8 divided by 2 is 4. If I go down an exponent, 4 divided by 2 is 2. So follow the pattern. If I go down another exponent, divide by 2, divide by 2, divided by 2. This, it would be 2 divided by 2, and I get 1. And that checks out. If you remember, A, B, C, D, E, all to the power of 0, anything is equal to 1. Which brings us to negative exponents. What do you think happens when you lower the exponent by 1? Do you think something different suddenly happens? Or does the pattern continue? I hope you said that the pattern continues, because it does. When the exponent goes down by 1, the previous number gets divided by a 2. This becomes 1 over 2. So $1 divided by 2 is 50 cents, right? Same thing. Let's keep going. If I subtract or lower the exponent by another 1, then it would be half divided by a 2. So let's talk. What is 50 cents divided by 2? Well, it would be 25 cents. It is a quarter. Now, hold on to this idea. 2 is there, a 4 is there. And if I were to lower the exponent one more time, that is, take the previous value divided by 2, a quarter divided by a 2 is 1/8. Please notice that there is a 2 and a 1 over 2. And above it is a 4, below is a 1 over 4. Above is an 8, below is a 1 over 8. I could actually rewrite these as 1 over 2 to the power of 1, 1 over 2 to the power of 2, and 1 over 2 to the power of 3. Long story short, here's the shortcut, because no one's got time to write all this every single time we have a negative exponent. When you have a negative exponent, all you have to do to resolve this is to get rid of the negative and write the base as its reciprocal. Let me explain. If you have some kind of fraction, a over b, and this is to the power of a negative number, 5, let's say, you can rewrite this as a positive 5 as long as the base is written as its reciprocal. The numerator becomes the denominator, and the denominator becomes the numerator. That's the rule. Okay? So let's try it. Going to our exercise sheet, I'm going to take an example right here. It's going to be, let's take something fairly simple. How about we try, snapshot this one. Okay, here's an example. I see a power of a power. So I could apply this power onto the entire base and say x to the power of -6 over y to the power of -3. Because you know, when you have a power of a power, the exponents will multiply. But you're going to end up with a lot of negatives. I don't like that. And you'll always see the question say, simplify, only use positive exponents. It's always going to be like that. A negative exponent is not considered acceptable. It means you could have done more to simplify it. Okay? So instead, here's what happens. By default, I really want you all to develop a habit. When the exponent is a negative, try to resolve it. Resolve it first. I am going to write the base as its reciprocal, where the y is now the numerator, x squared is now the denominator, the exponent is a positive 3. And now I can use exponent laws, the power of a power, to simplify further. Done. Let's try a harder example. For example, how about we go straight into some of these weird things? Let's do this one. This one looks interesting. This is question 29 from your back practice, so I'm doing your homework piece for you. This is question 29. Okay, so I've got, well, I have f, and f. They're all the same base, so I can use my exponent laws. When the powers of the same base are multiplying, I'll give you 3 seconds. What do we do? 3, 2, 1. The exponents are going to add, so it's negative 3 plus a 2 plus a negative 3. And if you could do the mental math in your head, this is f to the power of negative 4. And so that would be the end of your question, except this is not fully simplified. How do you deal with a negative exponent? Well, simple. You write it as a positive because you don't like negative. But the only difference is the f, the base, has to be written as its reciprocal. You might be thinking, Mr. Kim, you don't have anything on the bottom. Well, by default, any number has a 1 underneath. Like 5 is actually 5 over 1. 20 is actually 20 over 1. 1 million is actually just 1 million over 1. So f is actually f over 1. The reciprocal would be 1 over f. And we're done. You can leave it as that, or you can apply power of a power rule. This is 1 to the power of 4 over 4 to the power, f to the power of 4. And we're done. Let's try one more before we call it, and you have some time to practice this. Something a little harder. Ooh, maybe we can do this in preparation for your exit card, because who knows, maybe I'm gonna be super evil and give you something like this for 0.5 marks. I don't know, I'm just saying. Okay, let's try this. There's a lot of ways you can do it. Let me explain 3 different ways you can start. You can start by doing a division of these terms because they have the same base, A, B, B, C, C. You can try dividing first and simplifying. Or you can maybe deal with the power of a power and apply the exponent onto every single variable and coefficient inside because it's a single term here. Or because you don't like a negative exponent, you can deal with that and turn that into a positive 2. There's so many ways you can start. I'll show you one. I'm gonna deal with that negative exponent and write it as a positive 2. And what does that mean? It means, whoa. It means that the 3a squared b to the power of 3 and c to the power of 7 is now the numerator, and the negative 2a cubed b squared c0 is the denominator. Okay. Oh, and look, c to the power of 0, that anything to the power of 0 is a 1, so I don't even have to write this part. Let me clean this up. This is 3a squared b3 c7 over negative 2a3 b squared and nothing. That's just it's a 1. And why would I write a 1 when you're multiplying with 1? It just doesn't change. Next, let's keep going. This, if I apply the power onto the powers, this is 3 squared a squared squared, a to the power of 4, b cubed squared, b to the power of 6, and c to the power of 14, all over negative 2 times negative 2, 4, a6, b4. Okay, we're almost done. Y4 a to the power of 4 divided by a to the power of 6. Let me write it here. A to the power of 4 divided by a to the power of 6 is just 4 minus 6, which is a to the power of negative 2. But if you don't like that, you can always write it as 1 over a to the power of positive 2. And so I can write it in the denominator. B to the power of 6 divided by b to the power of 4 is b to the power of positive 2. And the c variable doesn't change. That's the simplified version. This one right here versus that one. I think the bottom one is cleaner. And that's exponent law number 5. If you can work through exponent law number 5, 1 to 5, using all this, you're in a really good spot, especially for chapter 7, the equations and the application that's coming up. So please practice. I'm gonna stop the video here. We're gonna call it the end of the first video. Please use the time you have to practice as much of this as possible, checking your answers with the answer key. In due time, we are going to move on to the second video, that is 7.4. What happens when we have a fraction? What does it even mean? Okay? Please work on this. Don't be on your phones, and practice for Friday. Suffer well.